Right, we'll look at transformers today. You've already seen transformers in the electricity topic in terms of the national grid. Okay, so already we know that a step-up transformer will increase the voltage, whereas a step-down transformer reduces the voltage. Okay, in this video we're going to talk a little bit more about how they actually work, and we're going to look at a couple of equations as well. So starting with how they work. So if you've got the red coil here, that we're going to call that our primary coil, and we're going to apply an alternating current to that, and it only works with alternating current, and I'll explain why in a minute. So let's say we've got the red coil, the primary coil, with a certain number of turns, NP. Okay, and we're going to apply a voltage across that, an alternating voltage, VP. Okay, so VP and NP. Now the blue coil is our secondary coil. That is our output coil with a certain number of turns, NS, for our secondary coil, and an output voltage, VS. Okay, so there we go. Now how does this actually work? Well, if you apply a current to VP, okay, then that we know is a solenoid. It's a coil of wire. It's solenoid. It's going to set up a magnetic field through the solenoid, which is going to set up a magnetic field in the iron core. Now, when that magnetic field gets established, that's a changing magnetic field, which is therefore going to cause a voltage to be applied across the secondary coil there. And this is why it has to be an alternating current as well. If it wasn't an alternating current, then the magnetic field would not be changing. And we know that if it's not changing, if you're not moving that coil through a magnetic field, or the magnetic field is not changing, then it's not actually going to do anything. It won't actually produce any secondary voltage at all. So it has to be alternating. We're going to assume that this has a 100% efficiency, and it will be pretty close to 100%. Transformers are quite efficient. So we're going to assume it's going to have a 100% efficiency, which means that power in is going to equal power out. So that we're not going to waste any energy heating up the core or anything like that. So P in equals P out. Now remember from the electricity topic as well, that power is equal to current times voltage. So the current on the primary coil times by the voltage on the primary coil is going to equal the current on the secondary coil times by the voltage on the secondary coil. And this is our first equation. Okay, and this tells us what happens to the current as we increase the voltage. So on a step-up transformer, if I increase voltage, then current has to go down in order to make this equation work. Okay, and just so you know, voltage and potential difference, pretty much the same thing in this case. And a step-down transformer is going to reduce voltage. Okay, and it will do the opposite thing to current. Okay, so it will do the opposite. So if it increases voltage, it has to reduce current. And if it reduces voltage, then it has to increase the current, okay, in order to satisfy this equation here. Now we also can have a look at how the coils are arranged. So we've got the first one with more coils on it than the second one, and this is what's going to cause the difference in voltage on the left and the right, and the difference in current as well. And we can relate the two together. Well, it's the ratio of voltages is going to equal the ratio of turns. So our equation will look like this: Vp over Vs. So the ratio of voltage from the primary coil to the secondary coil is going to equal the ratio of turns on the primary coil to the ratio to the turns on the secondary coil. Okay, so we end up with this equation here: Vp over Vs equals Np over Ns. Okay, and if you were given some values to work out, say, voltage in the primary coil or the secondary coil, you can just plug your numbers into this equation and you should get an answer from that. Okay, here's a quick question to look at then. So if a transformer's got 100 turns on the primary coil and 1,000 turns on the secondary coil, and the voltage across the secondary coil is 240 volts, calculate the voltage across the primary coil. Okay, so all you need to do then is use the equation. The equation is Vp over Vs is equal to Np over Ns. Okay, so let's plug in the numbers. So transformer has 100 turns on the primary coil, so 100 on the primary coil. Divide that by the number of turns on the secondary coil, 1000. Okay, so our ratio is 0.1. And then this is going to equal Vp over Vs So 0.1. And then what's the voltage across the secondary course? 240. So Vp divided by 240 is equal to 0.1. If you take 240 and you times it by 0.1, you will get Vp, which is going to equal 24 volts. Okay, right. I will see you in the next video.